Okay guys, so in this video we are going to talk about bundling architecture. So let's get into it. Now, what does that mean? Basically, what we're going to cover here is we're going to talk about the bundling process when you're running things through something like Webpack and how over time that bundling time actually increases. We're also going to have a look at how over time front-end's unit test execution and things of this nature actually takes longer as well. And then we're going to talk a bit about how to think about code structure to make testing a little bit faster and how we can basically what we can do when we already have tests that are inherently going to be slow. So let's just walk through this together because there's quite a lot of things to cover here. So the first thing I'm going to tell you right now is that when you are working on a large scale system, it doesn't actually have to be a large scale system, it just has to be a project that is fairly successful. At some point, you're going to notice that your accumulation of code is going to start slowing down your personal work process. Now, basically, the way that that manifests itself is that the more code you have, the longer it's going to take for Webpack and other bundling solutions to actually process all of that code. And it's the same thing with any project. If you're running things in a compiled language, for example, well, the compilation time is going to take longer the more code you have. Now, things that usually your code is going to slow down your bundling process, usually because of one of these three, well, all of the three can also be true here. Basically, you're going to have more code. You have code that needs compiling, pretty straightforward, right? If you don't need to compile, if you don't have to bundle it, then it's fine. And then things like static assets, like there's a lot of people these days who like to input something like CSS modules or CSS in JS as a part of their work process, and by bundling things in that through that pipeline, it's going to increase the load. Like the time it takes to bundle is going to go up the more files you have to parse and the more things you have to include. But what's also interesting is that this is going to affect your unit tests, because when it comes to unit testing, because I'm assuming of course that you're writing some form of unit test, maybe you're not, then this doesn't apply to you. But for those of you who are, these things also play a factor in your testing solution. And a few other things are noteworthy. Other things that might slow down your testing is that you have animations. Like one of the things that is very hard about unit testing in front end is that you might have front end components that have a visual element to themselves where there's a timing problem where an animation is running, or you might have some type of delay. Maybe you want to simulate a delay of some sort for a specific action and you have a spinner or something like that. There's many ways that you can think about this. So what I'm going to walk through here today with you is just a few thoughts on how you can strategize your development process so that these things actually become fairly sustainable over time. So let's have a look at the application first and foremost. So here I have this very simple little Hello World application, and there's more than one page. I have just another page here with a search filter and a really long list of numbers. And if I search here, it's just going to show me from, well, basically it's just going to allow me to filter the list based on a set number of some sort. So I can just sort, I can just cut off all the numbers that are below this number. And I have a second page for this as well that does the exact same thing. But these components I'm going to showcase two different versions or strategies for dealing with a specific issue. That's why I have two pages. So the setup here is fairly straightforward. I have a Webpack configuration here where I run through my TypeScript files with I pipe them through Webpack. Then I also have a Jest configuration here because I'm doing all of my testing with Jest. So we can actually see that in action like so. npm run test, I think. Did I set that up correctly? I hope so. Yep. So basically I have a few tests here that is going to run as part of Jest, or with Jest. There we are. There we are. You might have a hard time seeing that because I have so many tabs up. So great. Oh, actually, you know what? Let's do this instead. Let's go to my docs folder and go to bundling architecture and run test like that. More space, because these tabs, they're not really that important for you to see, because they're basically just there to run my post CSS scripts, my watcher for post CSS, Webpack, and the actual server that we're dealing with. And here you can see that all my tests pass. Yay! So let's talk about the first part here. So here I have my main application file. Now, one of the first principles that you should be aware of is that you need to have an understanding of how the bundling tree is going to structure itself, or how the dependency tree is structured is one of the most important things that you can keep with you. So what do I mean by that? Well, it's very simple. These are my 3 entry points. So this code here is the main file that my bundler is going to try to access. This is my entry point into my code. So everything starts from this entry point. This means that this code here, whatever I pull in here, regardless of what that is going to be part of the bundling. So if I add or remove things here, anything that is below in the tree is going to be pulled in with it. So I have 3 routes at the top layer, and if this route is really, really skinny and this is just a H1 element, right? Then it's all good and well, right? If this, however, is a really heavy route, imagine that this search page here has a lot of code. It has tons and tons and tons of legacy and CSS and bunch of stuff that is tied into it. Well, if I'm working on this route, but my bundling process is bundling all of this, the weight of this route is going to weigh down my development process. So this concept might seem very simple, but it's actually very important to know about this, because if this route gets really, really fat, or this route gets really, really fat, it's going to affect all the work that I want to do on this route here. Now, the easy thing I can do here, if I notice that this whole thing has actually become a bit of a mess, let's say that this route here is a bit of a mess, well, then I can basically just do this. I can remove this, or I can comment it out. Let's see if I can do that. Something like that, just temporarily, while I'm working on this thing here. But what's really important here is that in order for this to work, I have to have an understanding of how my dependency structure is, how that is structured. Because let's imagine for a moment that this page here is actually depending on things that are associated with this route here, then I'm not really going to save all that much, because if the shared dependencies between these 2 routes here are it's really, really high, I'm still in the same problem. So I'm going to simulate this with you by looking at create data. This is a little script that I made that is going to create this data.json file here. All it's going to do is that it's going to produce 1,000 numbers and put that to an array, and then just write that to a JSON file. But let's bump that up to 1,000,000. So let's kill that there. Notice now that the bundling size of my file is 1.2 megabytes. So what happens if I do this? Let's do node create data. Boom. Like so. And then let's go here and let's have a look at my bundle. Let's rebundle that. And that's going to take a little moment, methinks. There we are. Notice that the entire bundle size just shot up to 15 megabytes. Now that is a lot of JavaScript. Well, technically it's not JavaScript. Let's look at the component. So let's have a look at my main file here. So I have this search page here. Let's jump into that. So the search page here, it's a pretty skinny application, skinny page here. All it's going to do, as I was saying, it's just going to have some type of high number function that just does some console logging when I input some text, and then it has a list element. So what's going on with this list element? Well, this list element is the culprit. If you notice here that the data.json file, this is where this is being imported. Now let's just pretend, because I'm just simulating a really heavy data set, this could actually be your reality if you're bundling like translations and stuff like that, or a lot of assets. Or if you, by mistake, I don't know, import in the entire Material UI icons library or something like that. So this could be your reality. So in my node tree, this is the culprit. This component is causing my application to pull in all of this massive data. Now, let's also imagine that I can't really fix this in a nice way. Like I can't really just remove this because we're just pretending, right? We're just pretending that this is a set of nodes, like this could all be code, right? So what I can do now is that I can say, okay, I'll just remove this for now. And let's rebundle this again. Let's do that once. So I'm removing this node tree now, and this should now allow me to run much faster, but as you're noticing, it's not actually allowing me to go much faster because, well, I'm still at the same size here. And why is that? Well, as you probably guessed, yes, search page 2 is also depending on the list node. This is it's a very silly little example, but this is really important to understand. Because I understand that the shared dependencies between these two pages is the list element, and I know that the culprit in all of this, the reason why this is such a heavy bundling process for me, is because all the data that is associated with this node here. I can track down the issue, and I can very easily do this. I can do that. And what's going to happen now is that the bundling time is going to go down to the same thing basically the same thing that I had earlier. So now I can just be super happy and use my Hello World page and just work on this, and it's going to be super quick and super responsive, and I don't have to deal with all of these other pages. But remember, imagine if I didn't have such a clean architecture where I had a structure where I knew where all the shared dependencies were very clear and open to me, and I actually had some, let's say that the list element had to go into this component here, then I would be in the same sort of problem, right? So one of the fundamental things that you really need to understand in order to keep your bundling process really smooth and quick is that you need to have a clear architecture where it allows you to see the shared dependencies. So by having this modularized system where you basically just extract like everything that is interior, you may recognize this term called encapsulation. So you encapsulate all the things that are associated with a specific node or a component within your application into one directory, and then things that are shared, such as the list, you keep them separate. You can call this directory shared if you want to, but like I hope that makes sense to you. Things that are shared between your different routes should go into one category of directory, and the things that are isolated should stay the way they are. They should stay isolated so that you don't start and mix and match and depend on things right and left, because if you do that, it becomes almost impossible for you to smoothen out the bundling process for yourself. Now, let's have a look at our testing strategy, which is another part in all of this. So the search page here has a test. Now let's have a look at the search page spec file here. So what I'm going to do with the search page here is that I'm going to write a unit test, and all I'm going to do in this case, it's a very simple test. It's just going to take a snapshot and assert that this is correct, right? Now, as you can imagine, if I now have this massive super file here, which is part of the search page, well, here I'm basically pulling in the list, and this test, yeah, it's well, we can try it. Let's do npx jest, and let's do source public TypeScript search page, and let's do search page heavy, like so. So this is, I don't think, no, I'm not going to wait for this entire thing to be done because it usually takes a while, but it might go quicker now because I might already have a snapshot. No, it's just kind of lagging here. As you can imagine, this is really horrible. I mean, imagine you want to test the search page, but there's no way for you to do that because the search page is depending on the list element. And because the list element is so heavy and has so much fictive code associated to it, this test is now unbearably slow. So this is going to hinder your progression with unit testing because no reasonable developer is going to want to work like this. So what I suggest to you to do here is to take a look at the structure of this search page. Now, what's actually going on here? Well, in this trivial little example, the only thing that's actually happening here is that we're adding some type of high number function, and then we're rendering out an element, and that's pretty much it, right? So the problem here is that we can take the stance that we're just not going to test this because it's too heavy. It just takes too long to do this, and that is a fair strategy. You could ignore this because it's a fairly simple amount of logic, but imagine that it was a little bit more complicated. Now, I will suggest to you that you deal with this from two different perspectives. So one part is that we have logic here that we might want to test. This high number function. This logic we want to test as part of this entire flow here, but we don't want the execution and checking of this logic to be tied into the complexity and the weight of this list element. So what we can do is to do something like we did here in search page 2. So in search page 2, it's an identical, almost identical component to search page. The only difference here is that I have isolated the list element, and the other parts of this component has gone into their own elements. Now, why did I do this? Well, it's very simple, because if I have a search component like this, which is literally the same thing as this thing here, it's identical in every way. Well, what I've done is that I have created a situation where this piece of logic, just the structure here, has been isolated. And this is now possible, like this search spec here, this is going to run blazingly fast. Because the problem, remember, the problem isn't this code. The problem is the list component, because it's so heavy. So by isolating this piece of logic, I can test this very quickly. And when I want to test the search page as an entirety, I can't really do much about that, because if I want to test this entire component, I'm still forced to include this component in order for my test to work. But I can at the very least make sure that the search portion, or the search component, that's going to run very, very quickly. And the second part is this thing here, this function, make higher number. What's that? Well, high number is just a function. It's a higher order function that returns a function that encapsulates the logic that you saw in search page here. This is the same thing. It's just a higher order function that I can call and actually produce the function that I need in order to have it as part of my component here. And this allows me to also isolate this piece of logic. And here I have a test that is just testing the logic of that function. This is also going to run blazingly fast, because when I run this test, I'm not including, it's in its own file, and I'm isolating this code into this file here. So there's no connection to search page or to the list component, which means that that test is also going to run really, really fast. And as you saw earlier, if I just run npm test, notice what the tests that are now going to be executed. So it's going to run search, and it's going to run high number, which are both these two really, really quick tests that I can now iterate on, and it's a very pleasant experience for me as the developer. But notice also that the search page test, this thing here, that didn't run. Neither did this thing here run. Why is that? Well, it's because I have marked these two tests as heavy. Now, what's that about? I'm glad that you asked. So let's have a look at my package.json file. So there are certain tests that will always be heavy. Now, I'm just playing pretend here, but you will always have a situation where there are some tests that are either timing based or animation based or things like that. And a very cool thing that you can do if you're working with CI pipelines or things like of that nature is that you can allow some tests that are really, really fast to run in one process and then put your heavy tests in another process. And that's exactly what I'm doing here. I'm creating two separate commands, one command that is going to target the heavy tests and one command that is going to target the fast tests. So when I'm pushing something through a build pipeline or something like that, my operations team or my different coworkers who work in DevOps, they can now actually run up multiple processes and make all of these tests run really, really fast when I'm trying to deploy something. And when I'm working in my own personal workflow, if I'm just running the light tests, I can run the light test, and if I have to run a heavy test, I'm usually not going to run all of them. I'm just going to focus on one heavy test. This allows my entire workflow to be very scalable. And let's say that there are so many heavy tests in this specific pattern here that this is unbearable. Well, then let's just add another one. Foo heavy tests. And here we can just target a subfolder. So we can split this up over multiple processes until the heavy tests are not nearly as problematic as they used to be. We, unfortunately, of course, also have to invest in more resources in our infrastructure and things like that. But at the very least, the time is going to stay fairly low. So what I want you to take away from this is that if you're dealing with a scaling system or a successful system of some sort, you have to have a strategy for how to deal with the increasing amount of code, because before you know it, I promise you, you are going to have compilation times or bundling times that might be measured in minutes. In a build pipeline, for sure, if you're pushing things, if you're doing continuous delivery and stuff of this nature, it can take a long time. I've seen projects where the bundling time can take up to half an hour. And that's not the worst type of project. So by adopting a very clear architecture where you make sure that everything that is associated with a root node, like a route like this, that's all found in the same directory. That entire tree is now one isolated tree, and the only thing that it depends on are things that are shared. There's no intermingling between the different routes. This is just one clean tree. This is one clean tree. And then everything that is shared, like the list component or whatever shared components you have, is isolated as well. Then it becomes very easy for you to just remove certain routes that you might not be working on, or do something even fancier. This is just a simple example. I have another video where I show you a much more elaborate way of doing this. And then when it comes to testing, you should have the same mindset. Try to think of how you structure your components so that it will run really fast. In this scenario here, it's very simple. The list component is the heavy code. All of this other stuff is very light, so I can make these into their own components instead of just keeping everything flat in the file like this, which allows me to run those tests really quickly. And if that's the logic I care about, this is perfect. And for the heavy part, which is just running this entire test, I create a suffix to my file or something like that, such as .heavy, which allows me to now at least isolate the heavy tests so that we can add multiple processes in order to deal with all of the extra load that these tests are producing. Hopefully these tips are going to be useful to you. My teams and the people that I work with are extremely happy about the way that this works, and I can only swear by it. It's been working really great. Have a great day.